Test series 1, problem number 37 from digital, combinational circuits and timing. The given problem has this circuit. The problem says that the wires and the XOR gates are ideal and have zero delays. So the wires and XOR gates are ideal, having zero delay. There are two non-inverting buffers, S1 and S2, having S1 has a delay of 2 nanosecond, S2 has a delay of 4 nanosecond. At the input A, this waveform is applied. The time instant is 1 nanosecond. This is logic 0 and this is a logic 1. The question is to find the number of transitions happening at B. So we have to find the number of transitions happening at B, which means we have to find the transitions at intermediate points as marked. So let us assume the some points here. Let me call this 1, let me call this as 2, let me call this point as 3, and let us draw waveforms at 1, 2 and 3 to understand the solution. So at 1 we see this waveform. The transition happening at A happens at 1 after 2 nanoseconds because S1 delay 2 nanoseconds comes here. So you see a transition here at 3 nanoseconds. After that this stays high. The waveform at 2, this is bit tricky. The waveform at 2 is A XOR 1, which means these inputs are equal here, they are not equal here, and they are equal in this region. XOR is exclusive operation, which means it deducts non-equality. So here we get a 1 where there is non-equality and get a 0 at the place where it is equal. The time instance here is 1 nanoseconds because the wires and XOR gates have 0 delay. The time instance here is 3 nanoseconds. Now the waveform at 3. The waveform at 3 is due to S2, which has 4 nanoseconds delay, which means from the point where the 2 makes the transition, there is a delay of 4 nanoseconds, which means the transition happens at 5 nanoseconds, and the pulse width will be the same as this, which is 2 nanoseconds. The transition returns back at 7 nanoseconds. Now the output B is the waveform 2 XORed with waveform 3, which means we have, again this is not equal here, not equal here, they are equal here and here. Exclusive OR being a non-equal deduction operation, it will be a 1 here, then 0, then 1, then 0. So this is at 1 nanosecond, at 3 nanosecond, 5 nanosecond and 7 nanosecond. So this is 0, 1, 0, 1, 0. So this is the first transition happening this is the second transition, this is the third transition, this one is the fourth transition. So totally 4 transitions, which means the option is D.